the first question is give the meaning of elasticity. This kind of question basically have to memorize the definition. So I just write down the definition here to answer this question. Elasticity is the property of material that enables it to return to its original shape and size when the force that was acting on it is removed. So this definition, the keyword is return to its original shape and size. And when the force is removed. If I want to explain this definition in simple words, elasticity, maybe you have a rubber band. If you pull this rubber band, you apply force, but after some time, when I remove the force, the rubber band will go back to its original shape and size. So this is elasticity. So another example is, let's say you have a plastic scene. A plastic scene, if you pull it, you can change to different shape. It won't go back to its original shape. So we say that a plastic scene has no elasticity, but a rubber band has elasticity. So next question. The trampoline cannot be used anymore because it exceeds the elastic limit. By using the concept of elastic limit of the spring, explain why the trampoline cannot be used anymore. So notice that this is a 4 marks question. We need to explain. So how do we explain this kind of question? So we first find the keywords in the question. First, elastic limit, and they want us to use by using concept of elastic limit, explain why cannot use anymore. So this kind of question, normally how I do is I will look at the marking scheme and then I try to memorize whatever is required to get the 4 marks. But let's say now I don't have access to a marking scheme. So this kind of question, explanation question, if you have no idea what to answer, you can write down the definition first, because the definition normally have marks. So I will write down the definition for elastic limit, and then exceeding elastic limit is related to a law. So physics normally they like to test us on the concept, on the law of physics. So the law involved is Hooke's law. Elastic limit. Since this question is related to these two things, we first write down the definition for these two concepts. So what is Hooke's law? Hooke's law states that the extension of a spring is directly proportional to the applied force provided that the elastic limit is not exceeded. So this is the definition for Hooke's law. Then after that, you want to explain what is elastic limit. We write down the definition for elastic limit. The elastic limit of a spring is defined as the maximum force that can be applied to a spring such that the spring will be able to restore to its original length even though the force no longer acts on it. So we can clearly see that now we already write down the definition for Hooke's law and elastic limit. Ideally, we have to memorize the definition, and then the moment you see this kind of explanation question, you try to relate, see this type of question is from which topic, and then you just write down all the definition you memorize from that topic. Then there's a very high probability that you can get the 4 marks here, like some part of the 4 marks here. But usually it's still not enough. There's certain more that we have to explain. But before I go into that, I explain the definition. So Hooke's law, the keyword for Hooke's law is extension directly proportional to applied force. Then if elastic limit is not exceeded, this one is a keyword that must appear, because when we memorize the definition, it might appears like maybe sometimes we memorize not completely same as the one in the textbook, but then I believe that the meaning where the keywords that should appear in the definition is these few keywords. Also, in this kind of question, you can even plot a graph to explain it further. So this one is a Hooke's law graph. This one is force in Newton. This one is extension. So this is a graph of force and extension. Okay, imagine this is a spring here. Let's say this is a spring. There's a force pulling it. and this the extension x. So you notice when the force increases, when we pull the spring with more force, the extension also will increase. The spring sort of become longer. So this is initially before the elastic limit is exceeded. The graph is a straight line, which is what we mean by directly proportional. Directly proportional means it's a straight line graph. And this one is the elastic limit. So you'll notice after the elastic limit, the graph is not a straight line anymore. Then let's now look at what this means by elastic limit. Elastic limit means when we apply the force, we apply too much force to a spring, it cannot go back to its original length. You know that the spring, when we pull it or we push it, it will always go back to its original shape and size. But if we apply too much force on it, it will not go back to its original size. So the keywords here is elastic limit is. So I believe the keyword is maximum force. And then spring, restore original length when the force is no longer acts on it. So basically you just need to explain that elastic limit is the maximum force that we apply on a spring. After that, it is here, after the force is greater than the elastic limit, the spring cannot go back to its original shape. So this is what is meant by elastic limit. So now we already got a definition which I believe can get us some mark. We want to relate the definition to our questions. What I will do is I will say assume that trampoline, it actually obeys the Hooke's law. When the force applied on it is too large and exceeds the elastic limit, so when it exceeds the elastic limit, what will happen? The trampoline will not be able to restore to its original shape and size. So if it cannot return to its original shape and size, trampoline cannot be used anymore. Because we need it to remain elastic. So this I believe is done, but then I am not super sure that we can get the 4 marks with our explanation here. So the best thing is always look at the marking scheme of the question and memorize all the important keywords in it to ensure that we 100% confirm can get the 4 marks. But let's say we are not sure what's the keywords required in the marking scheme. Our best bet is always write down all the definition that we memorize in the particular topics, because usually the marks is given for a definition. And then of course after we provide the definition, we want to have several sentences to relate our definition to explain the question. Okay, now look at this question. As a material engineer in Baby Nova company, you are assigned to determine the most suitable spring to make a cradle spring. Table 11.1 show the characteristic baby's cradle spring. Give the reason for your choice. So this question, I believe the answers is the one with the largest force constant. Because my reasoning is because I believe the diameter, spring and type of material are not that relevant. Like it's not the most important characteristic for the baby cradle spring. But force constant is. So remember the Hooke's law said that F equal to Kx. So this is constant, the force constant. So we can also say that K equal to F over X. So if we plot a graph for the Hooke's law, remember our graph right here, the graph right here, F X. So the gradient of the graph will be the force constant K. If the K is very large, the gradient will be very steep. If the K is very small, the gradient will be very, very flat. So you notice for very large K, notice that for a large amount of force, there's only a very small extension. Large force, small extension. But for a small K here, for a small K, you notice there's a large extension for a small force. This means if you have two springs, and then this is a small K, and this is large K. If you put a mass to the spring, you notice that the small K with a lot of extension But if it has a large K, the spring will extend a bit. So it also means that, so if we have a very large spring constant, the spring will extend less. We will have a smaller extension. If we have a small K, we have a larger extension. That's why we want to choose a large K, which is 160, which is the largest K. We want the spring to not extend so much for the baby cradle, because let's say this is a baby cradle and this is a baby here, and the floor is here. The baby is some distance from the floor. So we don't want the baby to touch the floor, right? Which means the spring extension should be small. We don't want the baby to go all the way to the floor. So we want small extension. That's why we want small extension, means we want large force constant, large K. So we choose the P. Now next question. Now this is a calculation. Based on diagram 11.3, the mass of object A is 4 kg. Calculate the mass of object B. So this is object A. This is object B. So for this question, it's obvious that we are using Hooke's law. So the formula is F equal to Kx. In this case, all of them use the same spring. And then we know that the initial length 40 cm, so original length 40 cm. And then we also know that for B, LB is 50 cm, and for LA, because this is the length for object A, so I set LA equal to 50 cm, and LB for object B is 55 cm. And then we know that object A is 4 kg. So mass of A is 4 kg. Now, so we are provided with the original length and the length of the spring after it has mass A and mass B. But what we want is actually the extension. So how do we find extension? Extension, the formula is the length minus original length. Basically, we take the 50 cm minus the original length of 40 cm, we get the extension. So extension of A is LA minus original length, which is 50 cm minus 40 cm, 10 cm. And then of course we want to convert it to the SI unit, which is 0.1 meter. And next we want to get calculate the extension of the spring with object B. So we take length of B minus length, original length, is 55 cm minus 40 cm, which is 15 cm. So the extension for object B is 0.15 meter. Now we want to know the mass of object B. So how do we calculate that? We use a formula F equal to kx. But what the question is asking for is mass. So there's no m in this formula. So we need to think about it. For a spring, there's an object here with a mass m. So when we know that when there's a mass, there's a gravity pull down. So there's a gravitational force which is equal to mg. So F equal to mg. And then we also have F equal to kx. This is the force by the spring, F equal to kx. Since the object is not moving, we can say that mg is equal to kx because the force is equal and opposite in direction, so the object is not moving in any of the direction. So rearranging this, we have mg equal to x equal to k. So remember that we are using the same spring for both object A and object B. So we can rearrange it, become like this one. MA G over XA is equal to MBG or XB equal to K. So G, gravitational force constant, is also a constant. Gravitational acceleration, sorry. And K is equal for both the spring for the object A and object B. So we can also cancel this off because both sides have get MA XA equal to MB XB. Then we rearrange again. We want to find the mass of object B. So MB equal to MA XA multiplied by XB. So we substitute in all the numbers. MA is 4 kg, XA is 0.1, XB is 0.15, and we key in the calculator. So get 6 kg. Now let's look at the next question. Calculate the elastic potential energy. So we need to know the formula for elastic potential energy. Elastic potential energy is equal to half Fx or half kx squared. So in a Hooke's law graph, elastic potential is actually the area under the graph. So the reason this formula exists is because F equal to kx. If you substitute F equal to kx, you get half kx squared. So we just need to use this formula. For object A, the elastic potential energy is half k xa squared. We use half fx, half fx, and then f equal to mag xa, because f equal to mg. For MA, substitute in the value. The mass of object A is 4 kg, G is 10, and how about XA? Extension for object A is 0.1. Four times 0. 4 times 10 times 0.1 equal to 2 joule. Now we do for object B. Elastic potential energy is half Fx is equal to half mBgxB. So mass of B is 6 kg. 6 kg. Gravitational acceleration 10. xB, extension for object B is 0.15. Type in the calculator. .5 joule.